Hi, good evening. Can you hear me? Hello.
Yeah, I can hear you. How's it going?
Yeah, Alhamdulillah, everything is good. How about you?
Going on well. It's going on well.
Okay, good.
Yeah. Actually figured out how the LST was later figured out yesterday. Figured it out. We're
Okay,
just trying to extract the values from from the engine.
yeah.
Then we can have different tau. I think the way we present the data is what the editor was having issues with. Probably we need to also present tables of the send slope, the tau values, some other things, especially the different locations. So let me work on that and see when we share that, maybe it will be better.
Okay, so after the class, we will also discuss about that.
Sure.
So let's please start. Okay, can you see my screen?
Yeah,
Okay.
it's processing.
Okay, so basically today discuss about this topic, mainly agriculture land suitability. Okay, how we can easily work with the agricultural land suitability mapping to identify the suitable land for crop. Okay, and also livestock suitability mapping, both are the same process. Okay, livestock basically identify the grazing potential area using vegetation and water proximity analysis. So it's very important, and if you check some research paper, so we also find a lot of paper already published regarding this type of topic. So even if you check some paper I already published in year of 2022. So this paper, identification of suitable land for livestock production using GIS based multi-criteria decision analysis and remote sensing. So this paper, if you want, you can also follow, and then you can also try to make the suitability analysis and further make the research paper also. Okay, so this is the one kind of paper. So in this paper, it's talk about that suitability for livestock production. Okay, so basically suitability analysis is one of the most important concept in GIS and remote sensing, and it's widely used in agriculture, then urban planning, environmental management, disaster mitigation, water resource planning, then mining, and there's a lot of uses in GIS and remote sensing. And suitability analysis is method used to determine how suitable a specific area is for a particular purpose, such as agriculture, then livestock grazing, urban development, afforestation, water harvesting, mineral exploration. Okay, there are a lot of uses. The suitability analysis, basically which location are the most suitable for what I want to do. Suppose I want to identify livestock production. Suppose I have an area. So in this area, which place is more suitable for livestock production? Okay. So based on the different types of multi-criteria factors. Suppose I have a area. So this area I want to identify for mineral exploration. Suppose which area is more potentiality to get the mineral, different types of mineral. Suppose which area is more appropriate for the agricultural field or crop field. So this type of suitability analysis we can use and take the decision. So suitability analysis is a GIS based decision making process that evaluate the multi spatial factors and combine them to identify the most ideal location for a specific activity or land use. Okay, and we use the different types of factor, suppose soil factor, then slope, then water availability, temperature, rainfall, vegetation, land cover. So we can use the different types of factor for the different purpose of the suitability analysis. Okay, let me just open a code editor and show you that. Suppose if you check here, I already make the one analysis. Suppose this is the hilly study area in Bangladesh. So in hilly study area, I want to identify, suppose, agricultural land suitability. suppose which place I just use, or which place is more suitable for agricultural land activities. Okay, so if you check, we are just make some classification. So this type of green color, it's indicating about that highly suitable. This type of green color indicating about the highly suitable place for the agriculture or agricultural activities. This type of color. Then this type of color indicating about the moderate. Then this type of color indicating about the marginal. Then this type of yellow color indicating about the low suitability, and this type of red color is the not suitable for the agriculture production. So it's one kind of work for the agricultural land suitability analysis based on different types of factor. Suppose rainfall factor, then LST factor, then slope factor, hillshade factor, distance to river factor. Not only for that, we can also use the lot of factor, okay, to identify most suitable place for any kinds of purpose. So it can be agricultural land suitability, or it can be mineral potential zone suitability, or it can be urban development, okay, suitability, or afforestation, water harvesting, livestock grazing area. So different types of work we can easily handle by the suitability analysis. Okay, it's one kind of GIS based decision making process, okay, that evaluate the lot of factors. So here I include some factor, but not only for that. When you add the more factors, your suitability zone will be more good. Okay, we find out the more best place for identify for the different types of suitability region we can easily identify when we add the more factors. So if you simply, okay, let me the one code editor. So we can use the different types of factor for suitability. Suppose one factor is called the soil. It's very important factor, okay, for the soil. Then another factor, it can be slope. Slope is the another factor, okay. Then we can also use, suppose, water availability, okay, water availability. Suppose you want to make a farm, or you want to make the livestock grazing location, then you must need to consider, okay, which place have the water, okay, or distance to water. Suppose in this paper we try to identify, suppose we can see livestock production using GIS based multi-criteria decision analysis and remote sensing in this region. So in this paper we try to identify livestock production zone, we try to identify, okay, help of GIS and remote sensing. So in this case, if you check which types of factor we are used in this paper, so if you check, we just use at the land use land cover, so it's one kind of factor to identify. Then rainfall, okay, rainfall, this is another factor. Then water resource accessibility we also use. Then slope, okay, the soil types, okay, and also criteria ratio and standardizations. Basically this type of factor, soil types, then slope, water resource accessibility, then rainfall, then land use land cover. So this type of factor we are just evaluate to the identify livestock production area, okay, and then further we try to identify. So you can see, so livestock category we also identify. So suppose cattle, then sheep, okay, and we identify this type of factor, land use land cover, rainfall, water accessibility, mainly it's a distance to water or proximity to water, then slope, then soil type, okay, forward study area. And also you can see the for the sheep we are just use this type of factor, and also you can see the goat, okay. So different types of livestock. For the goat we are just use this type of factor. Then camel we are just use this type of factor, okay, for the, and then further you can check this type of map. So it's one kind of map, it's indicating about the land use land cover map. So this indicating about that rainfall map, okay, it's indicating about the slope map, it's indicating about the soil type map, it's indicating about that water availability, okay. Suppose for the water distance to water or proximity to water, so it's indicating. And then we just apply the assign the criteria weight, so we'll say at the weight, and this is the flow chart about that. So this type of flow chart we just work. And if you check land use land cover, okay, and finally we are just apply the soil types, you can see, and further it just create this type of classification map. Suppose highly suitable, moderate suitable, okay, or marginal suitable or not suitable. So this type of things it just work for the livestock. And same things we also done using the agricultural land identify. Suppose we can easily identify which area is that not suitable for the agricultural land or agricultural activity. So this type of green color indicating about the highly suitable. This type of green color indicating about the highly suitable region for agriculture. Okay, and this type of red color is not suitable for the agriculture. We can easily get the idea from here. Okay, so not only for that, there are a lot of uses in remote sensing and take the decision. Suitability analysis is a GIS decision making process. We can use the different types of factor, combine them to identify the most ideal location. Okay, so most ideal location for a specific activity. It can be agricultural land suitability, it can be livestock grazing production area, it can be mineral production area, mineral exploration area. So lot of purpose we are use this type of suitability analysis technique. Okay, and you can easily publish this type of paper easily for the identification of the suitable land for livestock or agricultural land. Okay, you can easily do. Right, so this paper, not only for that, if you want to check the other paper also, suppose simply search here, suppose agricultural land suitability. Agricultural land suitability analysis. So you find out a lot of paper. You can see this the agricultural land suitability analysis. Agricultural land suitability analysis by GIS and ASP technique. Just I show that paper. So this is the one kind of paper. So this paper work with the GIS and ASP technique to identify agricultural land use suitability analysis. And further calculated how much area for highly suitable, how much area for moderately suitable. Okay, just compute the area. And they are used this type of factor you can see. So in this time they are used at the capability class land use, then subclass soil depth, slope, aspect, elevation, irrigation degree, and other soil properties used to identify. Okay, so when you add the more factors, so your suitability zone will be more accurate. Okay, or if you check suppose another, suppose I simply search here mineral exploration suitability zone, mineral exploration analysis, simply search. So now you find out you can see mineral multi-credited geological data to analyze and for mineral variability mapping. Also in the application mineral exploration model, GIS, the general mineral potential maps, exploration target. So this type of paper, it just work for that suitability. Okay, suitability analysis to identify different types of factor related to the mineral. Okay, if you check, suppose as this may open. Let me another. It's not the open source. So this is the paper which a global scale exploration risks analysis technique to determine the best mineral fields for exploration. So there also use some factor related to the mineral exploration. Multi-credited analysis GIS. And not only for that, if you want, you can also do, suppose, different types of suitability analysis. Suppose types of analysis. Suppose one type we can do for land suitability analysis. Land suitability analysis. Suppose I want to identify agricultural land or forestry, okay, or livestock production. Okay, we can also do another type. Suppose we can say that environmental mental suitability. In this case, suppose you can do for protected areas or wildlife corridors or pollution risks. Okay, identify pollution risks area. Okay, then we can also do for another, suppose urban suitability. Urban suitability. So in this section, we just work with the roads suitability zone, roads or hospital. Okay, hospital or school or airports. Okay, to identify for the best location, suppose for the hospitals or airports, okay, which area is the most. So using the different types of factor. Okay, for the urban section you also do. Then suppose you also do for another, it's called that disaster suitability. Okay, so this is suitability we can also do for, suppose, flood zone assessment. Okay, flood zone assessment. So you already know about that, how we can identify flood prone area. Okay, so previous class I discussed about that, how we can identify flood prone area or landslide prone area. Okay, so we can also do, suppose, flood zone assessment. Okay, or if you want a landslide. Okay, landslide prone zones we can also identify. And suppose also drought. Okay, drought risks assessment. Or yeah, which place is the more drought, we can also identify in the disaster suitability. And finally another type, it's called the resource suitability. Resources suitability. So in the resource suitability, a lot of things we can either identify, suppose mining, for the mining suitability area, or groundwater research, okay, identify. Then solar or wind farm suitability. So this type of example easily do using the suitability analysis to identify. And we can also do, suppose, in the real life example, suppose agriculture. So for the agriculture, I already make the code in here. So first of all, I try to discuss about what is the theory about that. Then I explain the code. Suppose I want to identify for agriculture. So suppose when you identify any place, suppose I want to identify a agriculture production area. So which types of factor I need to identify? Suppose find the best land. Okay, find the best land where you just identify agriculture production. Okay, find the best land area, where, suppose, where I find out soil is fertile. So this is my one condition, soil is fertile. Okay, so suppose I have a place where I find out the soil is very good, soil is very fertile. So then I just choose it, it's a good agriculture production area. Then another factor I can consider, suppose slope is low. Suppose I want to make the agricultural land where slope is the low, because when you work with the high elevation area or high slope area is not good for the agriculture production area. So we consider slope is low. Okay, slope is low is the good place for the agricultural production. Then suppose I need to choose a place where the rainfall is optimum. Okay, so here we find out the rainfall is optimum position. I want to identify. Suppose I choose a place there is no precipitation, there is no rainfall, there is no distance to water is very far. So it's not the good or ideal location for the agricultural production. So for the agricultural production, I need to find out a place where the precipitation or where the rainfall is very good. Okay, I need to identify this place. So rainfall is adequate. Then suppose temperature, we also consider another factor, temperature. Suppose I choose a place where temperature, land surface temperature is very high. So this type of place is not suitable for the agriculture production. So for the temperature, optimal. Okay, I need the optimal place for the temperature. Suppose I just simply write here temperature. Temperature is optimal. This is my condition. And finally, it's very important. It's called the water accessible. Okay, suppose I agriculture production area must need the water. Suppose I can easily get the water from the nearby the agricultural field, so it will be another factor. So basically this type of factor we need when you work with agriculture production. Not only for that, you can also add the more. Suppose in this time, first factor, soil is fertile. Suppose I choose a place, find the best land where soil is fertile, I simply choose it. Then slope is low. Okay, just I simply ignore the high slope area. So slope is low. This is another condition to identify best agricultural land area. Then rainfall is adequate. Okay, then temperature is optimal and water is accessible. We can easily access the water. Okay, by the distance, by the river or any area, we can easily access. So minimum these 5 factors. Suppose I find out the one place. Suppose this place I find out all of factor is good. Okay, suppose this place is soil is fertile, this place slope is low, this place rainfall is adequate, this place is the temperature is optimal, water is accessible. So this type of things we can also do in here. Suppose you can see in this case I consider this type of green color indicating about that high suitability zone, because here I find out that soil is fertile. This type of green color I find out that slope is low. This type of place I find out precipitation is adequate. This type of place I find out land surface temperature is optimum. And finally this type of place I find out that water accessible easily we find out. So that's I simply use the GIS, this type of factor, and you can easily identify this type of green color is the high suitable zone. Okay, and this type of red color, suppose it's a high elevation, slope is high. Then suppose this type of place we find out that high temperature. Okay, as water accessibility is not good for this type of red color, so that's the reason is simply so that it's not suitable. So this type of factor we can simply consider. Suppose for the agricultural production, we need to choose soil is fertile, slope is low, rainfall is adequate, temperature is optimal, water is accessible. We can easily access the water from this type of place. So if everything is good, then we simply work this type of place is for agricultural production. Not only for that, we can also add the lot of factors. Suppose soil pH, soil nutrient. Okay, but minimum this type of 5 factors when you work, then we can easily identify which place is the best for the agriculture production area. So not only for that, if you want, you can also add here the more other factors, but this type of factor we must need to consider when you identify the best land for agricultural production. Suppose your land must need the soil is fertile, slope is low, rainfall is adequate, temperature is optimal, water is accessible. Then we consider this place is highly suitable. And we can consider in this type of place we find out that suppose soil slope is low, we find out the soil is fertile. This type of place we find out that temperature is optimal and water accessibility is very high. So that's the reason this type of green color it show the highly suitable place for the agricultural land production area. So this is the one example for the agricultural production area. Suppose now I want to identify another. Suppose I want to identify livestock grazing area. Suppose I want to identify livestock grazing areas. Okay, so find the best land for livestock grazing. So which type of factor I need to consider for that? So almost similar. First factor for the livestock, I need to consider good vegetation area, okay, or high vegetation area I need to consider for the livestock, okay, high ndvi or high good vegetation we consider. Then suppose livestock it's need the water for drink, so near water source. Suppose I just take a place where the water source is very near, okay, so this type of livestock animal easily drink the water. And also good vegetation area I need to choose, so here they can easily get their food, okay. Then near water sources, so this is another factor for. And then also important thing is that open land, okay, open land. And finally suppose we consider suitable climate, okay, suitable climate. So in the suitable climate we can add a lot of things. Suppose temperature is optimal, rainfall is adequate, okay, this type of thing we simply consider, okay. But most important, these two things, good vegetation, it's very important factor for the identify livestock grazing area. Where we find out the best area, we need to consider the good vegetation area. And then near water sources, it's very important. Then open land, then suitable climate, okay, for the suitable suppose temperature is optimal, what rainfall is adequate, then we simply choose this place is more suitable for livestock grazing. So in this I already show you this paper. So if you check this paper, suppose where is it? So this paper, it just work with the livestock, so same process, okay, to identify suppose water suitability or accessibility, all of those, or high ndvi place, okay. So same process, it also add the more factors, rainfall, water resource accessibility, then slope, okay, then soil types. So this type of factor simply use and further identify which place is more suitable for livestock grazing area, okay. So this is the example for the livestock grazing area, okay. If you want, you can also add the more other factor, okay. So which is very important. So in this time I simply add some important factor which is more important, but if you want, you can also add the more, okay. There is no limitation. Further, suppose I want to identify another, suppose I want to identify for urban planning, how we can easily use the suitability for the urban planning. For the urban planning, you can simply write suppose urban planning. Suppose you want to put a new industry area, okay. Suppose new industries you want to identify, so which place is the more better for the new industries, okay, for the urban area. Then suppose airports, so which place is more suitable for the airports setup. Then we also do suppose same, suppose hospital or schools. So this type of things we can easily identify, just use the suitability analysis. Okay. So there's a lot of uses: agriculture land area or livestock grazing area, urban planning, then mining. Okay, so we can simply add same process, but factor will be different. For the we need to use the different factor for the different suitability analysis. So now how I can set the weight? Okay, it's very important. It's called the weighting. Suppose how I can set the weighting. So let's discuss about that. It's called the weighting. So weighting weighting, basically it's called the is factor, does not have the equal importance. Okay, suppose if you check the livestock, so in the livestock section, all of factors does not have the equal importance. Okay, suppose some factors have the more importance, okay, some factor is the low importance, so we simply set some weight. Okay, so weight shows the influence of each factor. Okay, weight is that influence of the each factor. Suppose for that agriculture production, so in this time, suppose which factor is more importance: rainfall, slope, soil, temperature, or water accessibility. So it can be vary. Suppose in this case, I simply choose rainfall. So you can also set the weight manually, or if you want, you can also use the ASP technique. Okay, so ASP technique, I will try to show you the another class how we can apply the ASP, analytical hierarchical method. Then you can get the idea. But if you want, you can also set the weight. Suppose I set the weight for the rainfall. I set the rainfall, suppose 30%. In civil it was a 30%. Okay, I put the importance, suppose 30%. Then suppose I choose the slope, I just put the weight for the slope is suppose 20%. Okay, then temperature I put suppose same 20% importance or 20% weight. Okay, then soil fertile, I simply said suppose soil fertile is 30%. No, we just put the, so total will be 100. Okay, total will be 100. So I put it, suppose it's a 20%. I just keep the same. And water accessibility, I simply put suppose 10%. So you can simply set this type of weight. If you check 2 to 4, so total 100% we find out. So soil fertility, so you can also change this type of weight, no problem. Suppose which is more importance for the agricultural land production, we simply set the weight. Suppose in this case, I simply identify rainfall. Rainfall is 30%. I put the importance. Then distance to river, when you add, suppose you can also add the hillshade or distance to a river or land cover, temperature. So you can simply add the different weight. Weight, it display the influence of each factor. Suppose if I add all of factors, suppose for the agriculture identify, suppose I add the rainfall. Suppose I add the rainfall for 30%. Then suppose I add the another one, slope. I put the slope importance, suppose 20%. Then temperature. I set the importance of the temperature, suppose 20% same. Then I said suppose land cover, land use land cover. I'll put the land cover, suppose 10%. Then river distance, I said the river distance is 10%. Okay, so now we find out that suppose I add the another factor, soil fertility or soil nutrient, different types factors. I put the soil fertility. We find out that 3 to 5, 5, 6, 7, 8, 9, 10%. So we find out the total is the 100. Okay, total weight is the 100. We find out. So this is the process. So we simply create this type of factor: rainfall, slope, temperature, land cover, river distance, or soil fertility, as well as suppose same process, suppose good vegetation near to the water resource, open land, suitability. Then we set the importance. Okay, importance, it's mainly weight. So we simply add the weight. Suppose I put this weight is suppose for that 40%. I simply put. Then suppose I put here, it's a 30%. Okay, then I put suppose 20% or put suppose 10%, and then suitability climate I put suppose 20%. Okay, so we find out the total 100%. So we simply set the weight. Good vegetation or high NDVI area is the 40%. Near water source I put the importance 30%. Open land I put the 10%, and suitable climate I just put suppose 20%. So overall we find out that 100%. Okay, we set the weight. So this is the one process. So we can simply check our factors, and then we simply set the weight. Okay, and this weight further after put the weight, we need to apply the another method. It's called the combination. Okay, we need to apply the combination. In the combination, after setting the weight, we need to put the combination, or it's called the overlay combination, or we can also say it's a overlay. So in the overlay section, all layers, basically all factors are combined or compute the final suitable score. Okay, so all factor we simply combine to compute a final suitability score, and it's called the WLC. Okay, WLC, it's called the weighted, W for weighted, L for linear, and C for combination. Okay, WLC. So we need to combine mainly all factors. We just combine to compute the final suitability score. So it's called the weighted linear combination. Okay, so after calculating the final weighted linear combination, we need to set the Boolean overlay. Okay, Boolean overlay basically yes or no. We can also apply suppose MCDA. Okay, MCDA, it's called the multi-criteria decision analysis. We can also apply for that suppose ASP, it's called the analytical hierarchical process, when weights are grouped using the pairwise comparison. Okay, so weight are created by using the pairwise comparison, it's called the ASP. Or MCD, multi-criteria decision analysis, suppose I simply put the factor, this is the most influence to livestock production area, then I put the second, this is the second near water resource, this is the third, this is the fourth. Okay, so we simply set the combination. So after creating the final score, then further we simply reclassify. Okay, so this is the final step, reclassify. So in the reclassify section, final suitability we just simply divide it. Suppose we created the overlay or combination all of suitability score, we put the reclassify. So in the reclassify we simply set suppose highly suitable region. Second I put here suppose moderately suitable. We set marginally suitable, low suitable, and finally fifth, not suitable. So this is the step when you put any kinds of suitability analysis. Just apply the same process: land suitability, agriculture, forestry, or livestock or irrigation, environmental suitability, suppose pollution risks, or identify woodlife corridors. Same for urban or infrastructure suitability, road suitability, hospital suitability, school suitability, airport suitability, such disaster suitability, same. Okay, flood zone assessment, landslide prone area, drought risks, or resource suitability, identify mining potential zone, groundwater resource, solar, wind, or farm suitability. Okay, so there are a lot of uses we can easily do, but process is the same all time. So now if you check, just I try to explain this part, then you get the idea. So in this case, first of all, we need to create this type of factor. Okay, so which factor is influence the agricultural land area. So if you check here, I add the elevation. So this is the elevation. We can easily get the data from NASA SRTM. Mainly TM data, we can easily get the elevation. Then if you check, this is the rainfall. Okay, rainfall data we can easily get from chart satellite data, but if you have the grain station wise data, it will be more better, because charts is not the good resolution for the small study area, but for the big study area you can easily use the chart satellite data easily. And further, if you check this, the LST, mainly land surface temperature, so you can use the Landsat imagery to create the land surface temperature, or if you want you can also use the modis. Okay, so when you work with the small study area, try to use the Landsat imagery to get the more better result. Then slope is identify where is the high elevation, where is the high slope, where is the low slope, we can easily get it from the slope. Then hillshade, we try to identify hilly zone area, so this type of place is the hilly zone area, is identify hillshade area. And if you check suppose distance to river, it's very important, water resource accessible, so distance to river map. Okay, so distance to river, and then we are just use this type of factor. So this type of factor we simply use and just calculate, combine or overlay. Some first of all we need to set the importance. Okay, so in this time there are 1 2 3 4 5 6 factor I have. Suppose in this 6 factor, which factor is more influence for the agricultural land suitability, I need to identify which factor. So in this case I put the rainfall. Suppose rainfall is most important factor, I just consider, you can consider any others, but I consider rainfall. So I put the rainfall suppose 30%. Okay, rainfall is a 30% influence or 30% weight for agricultural land. Then suppose I put the slope suppose 20%, I consider 20% weight I set. Then temperature suppose I choose 20%. Then we will set suppose distance to water body suppose 20%. Then hillshade I choose suppose 10%. So overall I need to the 100%. Okay, 100%. So after creating this type of factor, we need to apply the weighted linear combination, WLC. We just put, okay, just a minute, I just take the connect my charger, just a minute. So the slope, then hillshade, distance to river, and finally just compute the agricultural land suitability zone and make the reclassify. After creating the weighted linear combination, mainly all of layers, then we simply just apply. So now I try to explain this code, then you can get the idea how it will work. So first of all, if you check, I take this type of data source. So I take the DEM data, mainly digital elevation model, DEM data, and create the DEM or elevation layer. So this layer we just generate using the DEM or NASA SRTM DEM. We simply create, and then we create this type of DEM map. So you can easily get this type of place is the high elevation, where is the low elevation, you can get the idea from the DEM data. So after the DEM data, we simply work with the land cover. So in this time I just use the ready-made land use land cover data set. If you want, you can also use at the Landsat imagery and create the land use land cover map. So in this case, if you check, I use the ES world land cover 10-meter data set. So it's provide globally 10 meters resolution land use land cover classes we can easily identify. So tree cover, shrubland, grassland or cropland, build up, okay, bare land, snow, permanent water body. So this type of class I can easily access from the land use land cover classification. But if you want, you can also create the land use land cover using Landsat imagery and also use this type of map, same process. And then I just create the precipitation. So for the precipitation, we simply take the chart satellite data. Okay, chart satellite data. I compute the total precipitation. Suppose for the annual, for the 1 year, we try to compute the total precipitation. And further temperature. So in this case, I just use the modis LST data set. Okay, but if you want, you can also use the Landsat satellite data. We already know about that, how we can easily compute the LST. So you can simply work for the Landsat when you work with a small study area, because when you work with the small study area, you need the Landsat satellite data. Otherwise, it's create the enlarged picture. Okay, so in this time I simply use the Modis LST data and create the average LST, and this is the LST level we simply add. Then from the DEM data we compute the slope. Okay, for we compute the slope and also create the hill shade. Okay, same. And now we simply choose the from the land cover. From the land cover we need to choose the cropland area. Okay, if you check, this is the land cover data set. In the land cover data set, which class give you the information for the cropland? We need to check it. So in this case, this is the tree cover, this is the shrubland, this is the grassland, this is the cropland. So cropland, this class number is the 40. Okay, 40 is the class number or value. So this 40 we simply mention because I want to identify agricultural land suitability or cropland area. So then I need to work with this class. So I simply just apply the land cover type equal 40. Okay, 40 is the class level. Okay, 40 is the class level for cropland area. Then we simply work with the distance to river. Okay, distance to river, we need to create distance to river mainly for the water resource. Okay, far from distance to river, we just create this type of map. So for that we simply use the data set. It's called the hydroshades data. So this is the hydroshades data. If you check, we can easily get that river network from this data set. It's also available in the Google Earth engine. Hydroshades follow-up direction. Okay, it's provide the this is the drainage direction we find out. Okay, it's globally available. Okay, it's generated from the DEM data. Okay, suppose we already know about that, we can easily download the DEM data and further we simply use this DEM data and some process, suppose follow accumulation, then flow direction, and then we simply compute the drainage direction or river network. We can compute it, but in this time it's a ready-made data set. We can easily get the hydroshades or drainage direction or river network. We can easily get georeference. It's provide the georeference data set, vector and raster. Okay, for the global it's available. It's a ready-made product we can easily use and get the hydroshade drainage direction. Not only for that, we also get that accumulation data set. Okay, so we can easily, you can see this is the another data set. It provides the accumulation, but this type of things it's generated by DEM data. Okay, using the NASA SRTM DEM data, it create the, you can see there also mentioned the topographic mission SRTM. Okay, NASA SRTM data set they also use, and they create the hydroshades flow accumulation. Okay, but it is also possible, suppose you can simply download the DEM data and further use the ArcMap software or QGIS software to create the drainage network or create the full accumulation, and further this type of product you can also use. But in this case, in Google Earth Engine, it's provide the ready-made product for the full accumulation or drainage network. We can easily get from this type of source. So I simply use this type of source. And river threshold, so basically for the 100,000 greater than 100,000 drainage area is considered as a river network. Okay, so in this time we just consider the distance to river. So just I put the threshold 1000 and take the drainage area greater than 1000. 1000 basically useful for identify only for the river drainage. Okay, only for the river drainage we just use, it's not fixed, but 1000 is work very well to identify river network or river drainage area. So just I put the drainage area greater than this 1000, and further we simply identify river network. So just call the drainage area update marks with the rivers and click with the study area, and further we create the distance, first distance from, just apply this formula, a square root clip with this and find out this distance to river map. So now if you check, we find out this type of map. Okay, so this type of place indicating about the far from distance to river. Okay, this type of blue color indicating about the very near to the river. Then suppose this type of green color, then yellow color, then red color. It just creates some class distance to river class. So and when you download this type of data as a GeoTIFF file format, you can also get the distance. Okay, then further make the classification. And for your research paper, you know, suppose you want to download the GeoTIFF and make the map, distance to river map. Okay, so now creating all of factor, we need to work with the normalize. Okay, In the normalize, we create the two class, suppose boolean 0 and 1, suitable and not suitable, only for the two class. So further this two class, we simply create the reclassify and create the total 5 class. Because why I need the normalize? Because I need to combine all of those. So that's why I need to create the normalize all of layer. So in this section, suppose is factor has the different unit. Okay, so if you check here, I add the different types of factor. Suppose I just add the elevation, it's a meter. Rainfall, it's a millimeter. LST, degree Celsius. Then slope, it's a degree. Okay, hillshade, it's a meter. Distance to river, it's a meter. So each factor has the different unit. But suitability analysis convert all layers to a common scale. So when you work with the suitability, all of factor I need to convert into a common scale. Otherwise, you can see that it's a different factor have the different unit: elevation, meter, millimeter, then degree Celsius, then degree, then meter, then meter. So I need to combine and I need to create the normalization, or it's also called the standardization. Each factor has the different unit. We are just, when you apply the suitability, you must need to convert all layers to a common scale. So all layers we need to convert all layers to a common scale. Suppose 0 and 1, 0 and 1. 0 suppose unsuitable, 1 suppose highly suitable. Okay, we need to normalization. So this is the second step, normalization. Into normalization, because all of factors have the different unit. But when I apply the suitability, must need to apply the same scale. Okay, suitability analysis convert all layers to a common scale, 0 to 1. So for the region, we simply apply the normalization 0 to 1. Okay, suppose in this case we simply apply the slope range 0 to 90 degree. Okay, suppose I simply slope divided with 90, assuming the slope range from 0 to 90 degree. Then precipitation normalization, so precipitation divided with 500, so we just assuming the annual precipitation range up to 1000 millimeter. Okay, then temperature divided with the 50. Okay, assuming the temperature is the Kelvin degree Celsius, and normalization. Okay, so we simply normalize 0 to 1 scale and then combine the all of factor with the weight. So that called the normalization. Suppose 0.2, it's at 20%. Okay, it's at 20%. Then add the precipitation normalization 30%, it's a 30%. Okay, it's a 30%. Then temperature normalization, it's a 20%. Okay, 20%. Then suitable land cover, okay, it's a 10%. It's a 10%. Then hillshade, it also 10%. Weight. Okay, and distance to river 10%. So 10%. So now total we find out that 100%. Okay, 3 2 5, then 2 1 2 3 5. So we find out the total 100%. We find out. So now after adding the weight, all of factor, after normalization, we simply add the weight, all of weight for the slope, then precipitation, temperature, suitable land cover, hillshade, distance to river. We simply add the weight. So now final, we simply set that suitability greater than 0. Okay, greater than 0, because when I make the normalize, it's just two class, 0 and 1. So I simply take all of values greater than 0. So I put the greater than 0 and take the final suitability. So this final suitability, further we simply add the layer. Okay, finally add the layer. We find out, you can see this type of agricultural land suitability. And if you check his total, we create this class. So it create basically, it's not the slope, it's a, okay, we need to rename it, then it will be more better. So let's just put the rename function. Rename. So it's a suitability. Run the code. Oh, what is the problem? Just a minute. Okay, I need to add it. Okay, later. Just now. Further, if you want, you can also add the color. So you can see it's the 0 and 1. Okay, basically it show the 0 and 1. 0 basically not suitable, 1 mainly suitable. Okay, so this 0 and 1 further we need to reclassify, and then we simply set. So this reclassify you can also do using the ArcMap software. Suppose you simply download this layer and then apply the reclassify in ArcMap software and try to display the result. Or if you want, you can also add the color. Suppose it just show the two class. Suppose if I just put that suitable